So this is the last example for the solving inequalities. This time both equations or both inequalities are not in slope-intercept form. So I'm going to have to do this for each of them where I change them where the y is alone. And I have the room underneath of this second equation. So I'll put equation 1 down there and I'll do equation 2 up here. So to get the y alone, I'm going to subtract x from both sides. So I'm going to get 3y is greater than negative x plus 6. And then if I divide by 3, I'm going to get y is greater than, remember that this negative x right here means negative 1x. So that's going to give me negative 1/3 x plus 2. For the second one, let me copy it again. It's 5x plus 3y is greater than or equal to negative 9. And again, I'm going to get the 3y alone by getting rid of the x term of 5x. So that's going to give me 3y is greater than or equal to negative 5x minus 9. And I'm going to divide by 3. So I get y is greater than or equal to negative 5/3 x minus 3. So let's look at our first one. This one has a y-intercept of 2. And it's a negative slope. So down 1 to the right 3, down 1 to the right 3. In the other direction, up 1 to the left 3, up 1 to the left 3. And since there's no equal sign, that means this one's going to be all dotted. And it says greater than. So greater than means that it's going to be above the line. So this is the region that would be shaded for that. Then I'm going to go back to my first actually inequality and graph that one. It's a negative 3 for the y-intercept. And the slope is negative 5/3, which means I should go down 5 and to the right 3. But if I go down 5, I go off the graph. So I'm going to reverse the direction. I'm going to go up 5, 1, 2, 3, 4, 5, and go over 3 this way. It still is going to be a negative slope because no matter what, negative slopes have to have the line sloping downward, but I just went in a different direction to get there, okay? So then now I'm going to go ahead, and this one does say or equal to, so this one does include the line. So we'll make it a solid line. And then it says greater than or equal to, so since it's running this way, above the line is almost the same thing as to the right of the line. So I am going to do it to the right of the line, or you can think about it as above the line, so that the line is a little bit more sloped. And then you should be able to see that the overlapping region is going to be here. So that would be all the coordinates that would have the ability to be plugged into the inequalities and satisfy both inequalities at the same time. So in the next videos, we will do a couple more examples. Some of them will be linear, but we're also going to focus predominantly on absolute value inequalities, which you've also done, but now we're going to be combining some of these with linear inequalities and finding a very different region that overlaps. So watch the next videos and that'll help you with practice for those.